Hello and good morning, everyone. My name is Safirul bin Muhammad Saufi, S for 8018, software engineering student, and today I'm going to demonstrate my prototype system based on my Peter 2 research entitled Data Integration Model for Dengue Monitoring and Control. The prototype system was made to produce forecast data for the possibility of an increase or decrease in dengue cases that occur in Puerto Rico. The system consists of two phases, which is the integration phase and the analysis phase. So what you can see on the screen right now is a tool that I'm using, which is the Talent Open Studio for data integration tool for me to make an integration model, which is consists of three different sources and will be combined into one source, which is a data warehouse. I'm actually storing my data. As you can see right now, I'm taking population KT and the KT random humidity, which is contained the temperature and the average humidity, like in every year in Puerto Rico itself, and the um, dengue report case, which is for Puerto Rico itself. And most of the data that have been taken is not really a real data. I was thinking of using a real data, but of course, of the authorization problem right now, so I actually using a dummy data instead. So right now, this is an example of taking data from different sources. So I'm actually going to integrate into one data warehouse using this model. So right now, after I'm actually connected, I can run. So building right now. As you can see, sorry, the computer may be having a bit of problem. So right now it's already recording. As you can see right now, this is not really a bit data, but this is what we can see the data that been transferred and already been combined into T, which is right now being passed through the T local one, and then being passed through again into my database, which is into my dengue related data on my data itself. So right now you can see the data that have been transferred, integrate, and combine are now being stored right here. So after that, we can use the system itself. So after the integration phases has done, we can go with the analysis system. And the analysis system is very simple. There's no need for input. So there's no need for any except for like input data itself. It's just all the calculation and all the data have been transferred are right now being analyzed and being calculated, which is background, which is in the background of the system itself. So right now I just click and all the data has been calculated. As you can see on the graph itself, I'm making a bit of like a comparison between the average of 5 years, which is starting for the latest data, which I only have 2019 as supposed to update it. So right now, 2019, prediction for 2020, which is the next year, the latest data we're going to use is 2019, and then 5 years pass, which is like average 5 years until 2005 itself. And then the population in 2019, which is the graph itself, can show the numbers of the average 5 years and also compare to the latest data that we have. So from that, we can make a comparison between the current population that we have, and also the average 5 years. So like I said before, if the population of the current year is actually bigger than the than the average 5 years, it's supposed to be increased by next year, which is possibly increased, not really going to be increased, but like I said before, this is a prediction data, it will be possibly increased. But if it's smaller than right now, it's like showing right now, it is smaller than the average 5 years, it's going to be decreased. Same goes right here. So annual temperature itself, because right now you can see average 5 years actually the same, and also same goes to this one. It's actually the same, so that's why it probably will not change by next year. Meanwhile, in average humidity itself, it's, it's already showing that the average humidity on 2019 is actually larger than average 5 years. So that means it will probably increase by next year. And of course, the reason is higher than average. And as you can see at the bottom itself, it's actually the overall result, meaning that maybe the dengue cases has actually increased or maybe decreased by next year, or maybe constant. So the other thing that you can do on the dengue monitoring and control center itself, you can see the whole graph of population and also the reported case and the death count by dengue itself in Kota Terengganu, and also the temperature and humidity in Kota Terengganu itself. So I think that's all for the system that I'm actually going to demonstrate. Hope you enjoy. Thank you.